Okay, so on this lesson for today, we're going to continue talking about the area as a sum and the area as a product. Okay, we're gonna set them equal to each other because when we express the area of a figure composed by tiles, the area remains the same. Okay, it's equivalent, but we can express it as a sum. And we also can express it as a product. Okay, so we're gonna do both as a sum and then as a product. And just like I said before, they're equal to the area, it's going to remain the same. Okay, so let's read the instructions. It says find the area as a sum and the area as a product. Make sure to label the length and the width of each model. Okay, so that's important. That's something that we have to take into account. We're going to label both of them. Okay, so this is my width and this is my length. Okay, so now let's look at the width. So I have this tile here and it's long. The length, the width of it, it's going to be the x. Okay, so I want to label it as x. Here, this one, we're looking at this side. So on that particular item, this is going to be a 1. Okay, so x and 1. So you can say that is x plus a 1, and that's the width. Okay, so now let's do the length. And the length, I have 1x. So I have x. I have another x. I have a 1, another x. I have a 1 and a 1. That means that my length is going to be equal to 1, 2, 3x, 3x plus 2. Okay, so that's the length and the width, x plus 1 and 3x plus 2. Okay, so now I'm gonna go here on my answer boxes. So the area as a sum. Now that's when we count how many how many tiles do we have. So if we look at the x squared tiles, I have 1, 2, 3. So I'm gonna say I have x to the second power, and then I have 1, 2, 3, 4, 5. So I'm gonna do plus 5x. And finally, I have 2 1 tiles, 2 unit tiles. So I'm gonna say plus 2. So the area as a sum is x to the second power plus 5x plus 2. Now the area as a product, that's when we look at the with the length times width. So we're gonna do length times width. And we know that the length is 3x plus 2. Close my parentheses, open another parentheses, and say the times the width, which is x plus 1. And you can do it like this, or you can also use the equation tool, which I'm gonna use that one for this other one, so that you have an idea of which one you could use, and you decide the way that you want to do it. Okay. So example number 2. For example number 2, again, so we want to identify the length and the width. So now this time I'm gonna say the width and I have more space on the length up here. So when I say the length is going to be this one up here now, because it's the same thing. Okay, so I have 1x, I have the length is x and x. So I have 2x plus 1, 2. So plus 2. And you could do it like that, or you can also type an equation and say 2x plus 2. If you want to make it bigger, you can select it all, and instead of 12, you can do like 16. Oh, right here. You can do 16, and now it's bigger. You can see it a lot better. So here for the length, I have 1x, 2x, and I have a 1 and a 1. So I have a 2x and plus 2. So I'm going to do equation and type it here, 2x plus 2. Okay. So now here, I'm going to go to my area as a sum. And again, that's when I count all the tiles. So I'm going to start with the x squared tiles, and I see that I have 1, 2, 3, 4. So say 4x to the second power. I do that to get the square. And now the x tiles have 1, 2, 3, 4, 5, 6, 7, 8. So plus 8x. And I have 4 1 tiles. And as you can tell, this one right here, I can make it bigger so that it's easier to see. Oh, that's how I move it, okay? And if you want to change the color, you can change the color here. Now the area as a product, let's work on that now. As a product, we have the length times width. So the length is 2x plus 2, so parentheses 2x plus 2. Close my parentheses, open another parentheses, times the width, which is again 2x plus 2, 2x plus 2. Close my parentheses, and now if you click here, you can allow it to move. You can change the color, you can make it bigger, it's your choice. But those are the two examples. Just make sure that when you're doing this, you put an equal sign here to tell me that they are equivalent. So the area as a sum is equal to the area as a product. The area as a sum is equal to the area as a product. Okay, because the area remains the same. It's just expressed to different forms. Now you can work on this for problems.